Hi, my name is Cyril Raj. My register number is 01 DAD 21 F1036. Hi, now I want to explain what is vector. As we know, definition of vector. In mathematics, physics and engineering, a vector quantity is a quantity that has a magnitude and direction of motion. The Euclidean vector is usually represented by a line segment in a particular direction, or graphically by an arrow, connecting the starting point A with the ending point B. For example, force, velocity, and momentum are vector quantities. Everything is quantities and direction in dimensions. Now, how vector help us to find out the direction and magnitude of an object. At the start and conclusion of a drag, the magnitude and direction of vector values are frequently employed. This is because it frequently simpler to see things like forces and velocities as magnitudes and directions at the start of the drag, and it is frequently easier to see the outcome as magnitudes and directions at the end. Vectors with the magnitude and direction must be visually represented using an arrow, with the magnitude being the length of the arrow and the direction being its arrowhead, and an angle or angles relative to some non-axis other directions. The component sort of a vector is frequently used for the middle of the matter because it is for easier to try.
Hi, I'm Gugendran from DAD 1A and my registration number is 01DAD21F1005. Okay, today I'm gonna teach you all how to do a basic vector in scalar. Okay, this is our question for today. Okay, now uh, we have to separate. We have to write back A times B and separate which one is I, which one is J, and which one is K. And okay, let's go for I, -2 and -3, -2 and -3, and for J, 2 and 1, 2 and 1, and for K, -5 and -5. Okay, now we have to make it bracket, and we have to take the I. If you want a I, you have to see J and K. So 2, -5, 1, -5, and minus J. This is formula. You have to follow the formula. Okay, if you want a J, you have to take I and K. -2, -3, -5, -5, and now plus K. Okay, if you want a K, you have to take I and J. So -2, -3, and 2, 1. Okay, actually this is formula. We have to fill it up with your question only inside. It's very simple. Okay, now you have to times. It's like 2 times for I, 2 times 5 minus 5 times -5 times 1. Okay, now minus J, -2 times -5 minus -5 times -3. Okay, and for K we have to plus. 2 times 1, 2 times 1 and bracket minus 2 times negative 3. And now this is our step, and now we have to calculate using our calculator, and the answer I got is negative 5 equals to I minus 5j positive 4k. Okay, this is for our today's lesson. Thank you.
The question I get is find the unit vector of OA equal to 3I minus 3J minus 2K and OB equal to 4I plus 5J plus K. Now we are going to find the unit vector of AB. Okay. This question will be same like metric question. OA times OB equal to first column we are going to put I 3 4, second column will be J negative 3 5, third column will be K negative 2 1. Second step we are going to times all of them. Open bracket negative 3 times 1 minus 5 times by negative 2 close bracket I minus open bracket 3 times 1 minus 4 times by negative 2 close bracket j plus open bracket 3 times 5 minus 4 times negative 3 close bracket k. Now we will get the answer 7I minus 11J plus 27K. This is our answer from the step given.
My name is Uma Mageswaran and my ID number is 01DAD 21F1014. Conclusion. A vector quantity is any quantity that has magnitude and direction, such as displacement or velocity. Vector quantities are represented by mathematical objects called vectors. Geometrically, vectors are represented by arrows, with the end marked by an arrowhead. The length of the vector is its magnitude, which is a positive scalar. On a plane, the direction of a vector is given by the angle the vector makes with a reference direction, often an angle with the horizontal. The direction angle of a vector is a scalar. Two vectors are equal if and only if they are of the same magnitudes and directions. Parallel vectors have the same direction angles but may have different magnitudes. Antiparallel vectors have direction angles that differ by 180 degrees. Orthogonal vectors have different angles that differ by 90 degrees. When a vector is multiplied by a scalar, the result is another vector of a different length than the length of the original vector. Multiplication by a positive scalar does not change the original direction, only the magnitude is affected. Multiplication by a negative scalar reserves the original direction. The resulting vector is antiparallel to the original vector. Multiplication by a scalar is distributive. Vectors can be divided by non-zero scalar, but cannot be divided by vectors. Two or more vectors can be added to form another vector. The vector sum is called the resultant vector. We can add vectors to vectors or scalar to scalars, but we cannot add scalars to vectors. Vector addition is commutative and associative. To construct a resultant vector of two vectors in a plane geometrically, we use the parallelogram rule. To construct a resultant vector of many vectors in a plane geometrically, we use the tail to head method. Thank you.